Hello everybody, it is time for yet another worksheet answer key video. This one is about lesson 8-5, problem solving with trigonometry. So here sometimes we will have 30, 60, 90 triangles or any version of our right triangles, and sometimes we won't. And we'll have to know which kind of trigonometry to use to solve. So for the first one, Leah is asked to find side AC. What is her error? So she was using, to find AC squared, the law of cosines. But she used the word sine instead of cosine in the law of cosines, which of course we can't do. So she used sine instead of cosine in the law of cosines. Cosines. Oops. That's it. Number 12, find the length of the diagonal of the isosceles trapezoid, then find the length of the fourth side. So we've got two triangles here created by the diagonal in our trapezoid, which means we can use laws of sines and cosines to find our missing pieces. First, to find the length of the diagonal, I have a side angle side configuration, so I can use the law of cosines to find the missing value of x here. I can say x squared equals 4 squared plus 4 squared minus 2 times 4 cosine of 80. And when I do that, I find that x squared is equal to 26.4. Take the square root of both sides and I get x equals 5.14. So the diagonal of the isosceles trapezoid is 5.14. Then I can find the rest of the isosceles trapezoid, or the other top side. And I can do that by remembering that isosceles trapezoids have these sides of the trapezoid, or not sides, these angles are supplementary. So if this angle down here is 80, then that same side interior angle up here will be 100. And since the trapezoid is isosceles, the other top base angle will be 100 as well. So now I know some things about my other triangle, including an angle side pair, which means I can use the law of sines to find the length of the top side. So I can say that the sine of the angle I know, 100, over that opposite side, 5.14, is equal to the sine of 30, right? Because I also know down here that this angle is going to be, since this is an isosceles triangle, this angle is going to be 50, okay? And so then I've got sine of 30, sorry, the 30 comes in because it's over here to make up 80, sine of 30 over y. So then I'm going to use the law of sines, cross multiply there. I get the 5.14 sine of 30 equals the sine of 100 times y, or y sine of 100. Then I'm going to divide both sides by the sine of 100. So 5.14 sine of 30 over the sine of 100 equals y. And since I know that that is equal to y, that means that 2.61 is equal to y. So we have x, the diagonal of the shape, which is 5.14. And we have y, the top of the shape, which is 2.61. Number 15, what is the angle of elevation to a building 1,000 miles away that is 300 meters high? Well, let's draw this. We've got a 300-meter building that is 1,000 miles away. We're trying to find the angle of elevation. It looks like, compared to this angle, I have the opposite side and the adjacent side, and I know it's a right angle because I'm using angles of elevation in right triangle trigonometry. So I'm going to use tangent with opposite and adjacent because of SOHCAHTOA. So I'm going to say that the tangent of angle x is equal to opposite over adjacent, 300 over 1,000. And in order to find x, I've got to take the inverse tangent of both sides. So the inverse tangent of the tangent of x is just x. And then the inverse tangent of 300 over 1,000 is something I can just put into my calculator. And that's going to give me x equals 16.7. So 16.7 degrees is the angle of elevation according to or going to that building. Next, I've got another one. To what angle of depression should the security camera be adjusted in order to have the lens aimed at point P on the ground? So since this is an angle of depression, we can do it a couple different ways. We can say, well, this angle is the complement of this one right here. Or we can sort of build out our other triangle, which is what I'm going to do. I know that this distance is 6 meters because the distance on the other side of the rectangle is 6 meters. And I've got a right triangle, so I'm going to use right triangle trigonometry to find the angle. I also know that the 12 meters is the length of sort of the beam of the camera, or the distance from the camera to this point on the ground. So as with respect to this spot in my triangle, I know the opposite and the hypotenuse, which means I'm going to use sine, like SOHCAHTOA sine. So the sine of the angle I don't know is equal to the opposite 6 over the hypotenuse 12. Then we can, of course, find the inverse sine of both sides, which would give me x equals the inverse sine of 6 over 12. You can run that through a calculator or use what you remember about the sine of 1/2, and that is x equals 30 degrees. So the angle of depression is 30 degrees. Right. Next, we've got another angles problem. We've got another right triangle trigonometry problem because we've got angle of elevation. The angle of elevation to the sun is 21.5 degrees. What is the length of the shadow cast by a person who is 5 feet 6 inches tall? Well, 5 feet 6 inches is a mixed unit number, but I know that 6 inches is a half a foot, so that's just going to be 5.5 feet. I'm just going to convert it to feet there. And I want to find the length of the shadow, which would be on the ground there. That's x. So I have, with respect to this angle, the opposite and the adjacent side, which means I'm going to use tangent. So tangent of my angle, 21.5. Oops, messed that up. Give me a minute. 21.5 is equal to opposite 5.5 over adjacent x. Multiply both sides by x. I get x equals, well, not x equals yet. I guess I'll write all the steps in here. I get x tangent of 21.15 equals 5.5. And then since the tangent of 25.5 is just a number, I can divide both sides by it and get x equals 5.5 over the tangent of 21.5. And when I run that through a calculator, that tells me that x is equal to 14.3 feet of shadow. Number 18. Libby's eyes are 5 feet above the ground. So if she's over here 5 feet above the ground, there's also a 5-foot space way over at the monument there. And the angle of elevation of her line of sight to the top of the monument is 74 degrees. How far is she from the monument? So of course we've got a right triangle here. It's just tilted because we are in perspective, but we know that any monument is going to be at a right angle with the ground. So we're going to say that according to the angle of elevation we have, we know the opposite side and we're looking for the adjacent side. So we use tangent. So the tangent of 74 degrees is equal to 555 over the adjacent side, x. Multiply both sides by x, and then also divide both sides by the tangent of 74, which gives you x equals 555 over the tangent of 74. So I just did 2 steps at the same time there. You can see up above for those steps broken down. And then if I put that into my calculator, oops, I shouldn't say, should I say 555? No, I shouldn't. Hold on 1 second, I made a mistake. Since this is 555 feet tall, but her eyes, which means her right triangle being made is 5 feet off the ground, we're only going to be looking at 550 feet of that monument because 5 of those feet are underneath her line of sight. So rather than doing 555 in these problems, we're going to use 550 because the rest of it is not part of the right triangle we created. So if we do 550 over the tangent of 74, we get 157.71 feet. So how far is she from the monument? That is how far she is. Okay. 20 and 21, we want to find the area of these triangles. In 20, we have this side. Well, we have 2 of the sides and we have the angle between them. That makes it easier once we have 2 sides and the angle between them, because we need base and height in order to make a triangle, or in order to find the area of the triangle rather. And I have everything that I need to find the height of the triangle because I know these 2 pieces of information. When I draw in the height, I create a right triangle, and I can use the right triangle trigonometry rules to find this length, because according to 51 degrees, or if I stand on 51 degrees, I want to know the opposite, and I have the hypotenuse. I'll use sine. So the sine of 51 degrees is equal to opposite x over hypotenuse 6. Multiply both sides by 6, so 6 sine of 51 equals x. Run that through a calculator. 4.66 equals x. 4.66 represents the height of that triangle. So to find the area, I'll do 1/2 base times height. So 1/2 of 4.66 times the height of the triangle, or sorry, of the base, which is 7. And that is going to give me 16.32 as the area of the triangle. The next question is a lot more in-depth because we have the 3 sides of the triangle. So the first thing we need to do in order to find its area is we need to find one of the angles in the triangle. That's our starting point. So let's go ahead and find this angle right here. And I'm going to use the law of cosines to do that. So opposite side first, 4 squared equals 7 squared plus 6 squared minus 2 times 7 times 6 cosine of x. Simplifying there, we get 16 equals 7 squared plus 6 squared is 85. Minus 2 times 7 times 6 is 84 cosine of x. Subtract 85 from each side. That gives us negative 69 equals negative 84 cosine of x. Divide both sides by negative 84. We get 0.8214 equals the cosine of x. Got to find the inverse cosine of both sides of that to find x. Equals x here. So that, according to the calculator, is 34.77. So the angle we're looking at is 34.77 degrees. Awesome. Now we just need the height of the triangle. And we can do a few different places of finding the height. But if I found this particular base, I'm going to try and find this height. Okay, or if I found that particular angle, rather, I'm going to try and find that height. And I can do that because if I'm looking for the height, I can use sine, opposite, and hypotenuse. So the sine of 34.77 equals x over 6, multiplied by both sides by 6. And run that through the calculator. You get 3.42 is equal to x is equal to the altitude or the height of the triangle. So then I'll do my 2 perpendicular measurements, base times height. 7 times 3.42 over 2, or multiplied by 1/2. And that's going to give me 11.97 as my area. Number 24, Benito aims for the center of the target from a distance of 70 meters. If Benito shoots the arrow at a 0.055 degree angle of depression below the center will he hit the yellow circle, and explain. So here's the center. Let's draw a line out over to his hand, and let's talk about where he's aiming. So he's got an angle of depression here. I'm going to make this sort of an exaggerated triangle a little bit, if I can. So the angle of depression is this angle right there, and that is 0.055 degrees. And he is standing at a distance of 70 meters away. Ooh, let me put that somewhere else. Okay, so what we're actually looking for is we're looking for this opposite side length. We know that the diameter of the target is 12.2, but we don't know how far above or below the target Benito is shooting. That's what we're looking for here. And if I'm standing on the 0.055 degrees, I'm looking for the opposite side, and I have the adjacent side, since the right angle in my triangle will be right at the bullseye. So then I'm going to use tangent. So the tangent of 0.055 is equal to opposite x over adjacent 70. Multiply both sides by 70, so 70 tangent of 0.055 is equal to x. Run that through a calculator. 0.067 equals x. And since we did our work at 70 meters away, our answer is also going to be in meters. 0.067 meters. We move the decimal point 2 places to the right to find it in centimeters, so that's 6.7 centimeters. So then we think, okay, if from the center of this circle, he's down 6.7 centimeters, is that inside the circle or not? We'll take the 12.2 centimeters and we'll divide that by 2. Whoops. 12.2 divided by 2, that's 6.1. So the radius of that yellow circle is 6.1. If he's 6.7 centimeters away from the target, or from the yellow center, he will be outside the yellow circle. He will be outside the yellow circle. Sounds good. Number 26, what is the area of the triangle? It is, again, a triangle where we can go ahead and draw an altitude into it. And we can use the signs because we have the hypotenuse. We're looking for the opposite, and we have an angle. So there's x. We can say the sine of 24 is equal to opposite x over hypotenuse 6. Multiply by both sides by 6, so 6 sine of 24 equals x. Run that through your calculator. You get 2.44 equals x. And so that's the height of the triangle. We do base times height divided by 2, or 1/2, times 2.44 times 7. And we end up with 8.54 as the area to the nearest square unit. Number 27, which of the following equations is true? So we've got a whole lot of stuff going on here. We're going to have to think through these things. Statement number 1 says tangent B equals 4/3. If I'm standing on angle B, tangent is opposite over adjacent, which is something we don't know, over 3. So 1, that's not true. And I want to go more through the center than that. Good enough. Number 2, AD is equal to 2 square roots of 7. How could we find that out? We can find the length of this piece and use a 30, 60, 90 triangle over here at ACD. So I can use the Pythagorean theorem to find AC. So that's going to be x squared plus 3 squared equals 4 squared. And that's going to give me x squared plus 9 equals 16. Subtract 9, x squared equals 7. So x, the height there, equals the square root of 7. And since this is a 30, 60, 90 triangle, I know that the hypotenuse of a 30, 60, 90 triangle is twice the length of the base, or twice the length of that short side. So the hypotenuse is indeed 2 root 7. Number 2 is correct. Number 3 is us writing out the formula for the law of cosines, and that's using AB, this piece right here. AB squared is equal to the other two sides, BD squared plus AD squared, minus 2 times the other two sides, BD times AD, cosine of the opposite angle to the side we're looking at, cosine of 30. So that's true as well. So 2 and 3 are true, which means D is the answer to the question. Hopefully that helps. Let me know if you've got any questions, and have a wonderful day.